So let's get rolling. So very first thing I thought would be, it's a good idea to look at where we're going. So if we look at this topic, we have 6 lessons or so. Today it's going to be around kind of central tendency, or where the middle of the data is. The next lesson is about how spread out data is and how we measure that. Then we talk about something called the box and whisker plot, which is a graph that shows us information about a data set. Then we're going to talk about grouped data, so data in tables and data in summaries. Then we are going to do grouped data graphs, which is going to be like histograms and frequency polygons for lesson 5. And then lesson 6 will be about ogives, or cumulative frequency curves. So let's have a look at where that is. So 1, 2, 3, 4, 5, 6. And then I will talk about things called outliers and skewed data as we go along. So give me a thumbs up if that stuff looks vaguely familiar to you from stats. I think some of the histograms and frequency polygons are new, but if that looks like what you remember roughly from grade 10, let me know. And if it looks completely unfamiliar to you, let me know as well, because that's also useful. Okay, well, it looks like we're broadly in the right area, so let's get started. So when we talk about statistics or data handling, we talk about data being in words. Words is qualitative, like, ABCs and things like that. And then we talk about quantitative data, data in numbers. And the focus for your grade 11 stats is going to be on quantitative data, or data in numbers. And the 2 areas we distinguish are discrete data, so data that occurs in whole numbers without pieces that are like extra fractional bits. So if I count the number of fingers on my hand, even though this one's smaller, I still have 5 fingers, and you can't have 5.5 fingers really. You have fingers or you don't. Or we could talk about discrete data like the number of people in the room. But you also get other data which you measure. So you maybe how tall you are, or how much you weigh, or what the temperature is today. And that can have fractional pieces, and we call that continuous data. And so it's important to think of the fact that data is mainly going to be in numbers in this section, even though data can occur in words and letters and stuff. And then these 2 subdivisions. Okay, so let's just do a little bit more on the notes. So discrete data can only take on certain values. The example they give is the number of students in a class. You can't have half a student. Or the sum of 2 dice. So you could have the sum of 2 is the minimum value, and the maximum value for the sum of 2 dice is 12, but you can't have 11.5. Okay, so that's discrete data. And continuous data is data that can take on any value within a range. So a person's height can be any value within a range. It can be like 1/2 centimeter, or it can be 1/4 centimeter, or it can vary like that. Or the time you take in a race. So if you watch Formula 1, they go to thousandths of a second, or a 100-meter race, you go to hundredths of a second. And so this is an example of continuous data. Give me a thumbs up if the basic idea of the difference between continuous and discrete data makes sense to you. Thumbs down if it feels very odd still. Let's have a look at those hands. Okay. Well, let's put this to the test. Let's see how. So here's a multiple choice question. Tell me what you think the correct answer is. What do you think is the correct? Okay. What do we think the correct answer is there? So it's asking for discrete data. And I think that this is continuous, that's continuous, that's continuous, but that one is discrete. Because the number of brothers or sisters, is either 1 or 0, or it can't, even if they're small, it can't be a half. So the correct answer is B, and that's discrete data. Okay, let's do another question. Which of the following is continuous data? Which of the following is continuous data? So that looks like it's discrete, 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 but this looks like it's continuous. And so the correct option is going to be C. So the way I remember it is we say that discrete data is data that you can count, whereas continuous data, so continuous data is data that you measure. So you measure your height, you measure your food, the weight of your food, that's continuous data, whereas stuff that you count, we class as discrete data. Okay, cool. All good there. So if we now talk about data, we also have a choice. How is data presented to us? So one of the main ways that data is presented to us is as a list. Okay, so this is a list of data, and we are going to calculate measures of central tendency for this list. And the 3 measures of central tendency are the mean, the mode, and the median. Okay. If we look at this data set, the mean is simply adding up all the items and dividing by the number of items. The mode is the one that occurs the most often. And the median I'll discuss in a bit. But tell me, I want you to find A, what is the mean of this data set, and B, what is the mode? See if you can do that now. So for the mean, I need to know what n is, and n is the number of items. So I guess So I get 12 items in my data set, but that's not going to be the mean. It just helps me. I see some students are saying they know what the mode is, which I'm tending to agree with them. So in order to find the mean, I have to add up all of these items on my calculator and get a total. So what total are you guys getting when you add up all the items? What are you getting for your total? So Levo has said 1961. Did anybody agree with that? Okay, Clamelo agrees. So Fatejo agrees. So now to get the mean, I need to take 19. Now there's a couple of ways to do this, but for now I'm just keeping it simple. So 1961 divided by 12, and I get 163 0.4, so 163.42. Now, what is the mode? Well, the mode is simply the one that occurs the most often, and the only one that occurs twice is 155. So in terms of measuring where the middle of this data set is, the average or the mean is 163.42, the mode is 155. I haven't done the median yet. I left it out. Now, why do you think I've left the median out for now? What made the median a little bit harder to do than those first two? And you can raise your hand and tell me, or you can put it in the chat. What's different about the median? So you have to arrange it. Yes, the technical term is you have to rank the data. And so at the moment, my data is not ranked from smallest to biggest. And so it makes finding the median difficult. So what I want to suggest is that we take a moment to order my data so that we might find where the median is. The median is where the middle of the data is, going from smallest to biggest. So my minimum value is 149. So let's take that out. And then I see 155. Oh, wait, no, I've missed 154. And that's why we cross them out as we go. Then 155. So we'll do that. Then what comes after that is a 159. Then there is a 162. 166. What's left? 167 or 168 or 169. There's lots of people who are in the 160s, it seems. Then it's so 169, and then what is next? It's 175 and 182. So let's just check. I've still got 12. 1, 2, 3, 4, 5, 6, 7. Okay, cool. So this is called ranking the data or ordering it from the smallest to the biggest. Find me the median now. And what I do is whenever I find the median, I use a position calculation first, and then I find the value. I'm using the notation Q2 to be the median. And I'll explain that later in the lesson. I'll give you a bit of time and then, okay, so for Tejo, this is the way I would do it. I would say, how many items do we have? Well, the N value, the number of items in the data set is 12. And so I first do this calculation called the position calculation. Where is the position of Q2 or the position of the median? And so I go a half times 12 plus 1. And if I go to my calculator, the position of the median is position 6.5. So the 6.5th position. So now I go to my list and I go 1, 2, 3, 4, 5, 6, 7. The median falls between 162 and 166. So how do I find it? I simply average out those two values. I go 162 plus 166 divided by 2, and I get 164. So if I got, my position was the 6th position, it would have been 162, the value of the median. But because it fell between two values, I averaged them out. And the median divides the data into the lower half and the upper half of the data set. And so the answer here would be 164. And what we notice is that the median or the three measures are not the same. So these three measures of where the middle are do differ a little bit. I'm going to give a moment for questions or comments. Are there any questions or comments or things you want me to go into further detail with? Otherwise, I'm going to move on. Okay. Now, this is an example of data which is in a list, but we can also put, so what was the 6.7th position? when you're dealing with quartiles for Tejo, you always average out between the two nearest values. Is there a way to use the stat on the calculator? There is, Cass. I'm going to do that in a future lesson. For today, I want to keep it just basic, but I absolutely will show you all the tips and tricks on your calculator. Okay. So you do still get full mark for Zama, but for today, I'm focusing on the ideas. I will bring my calculator to the lesson. Yeah. So Kat, if it falls between, okay, so for everyone's unsure about what we do, if you're talking about quartiles or the median, if it falls between two values, you simply take the average. So what I did here was I took the two values, I added them, and then I divided by 2. Okay, it doesn't matter if it's 0.25 or 0.75. If it's between, you just average it out. It's a little bit different with percentiles, but I'll talk about that in a future lesson. I don't want to do much today. Okay, now, the second big thing we do in the session is we group the data into intervals. So instead of thinking about this as a list of data, we put the data into a table. What do you think would be good intervals for this set of data that I've just shown you of heights? What would be a good set of intervals to put them into? Who has some ideas? So what interval, if you wanted to summarize this data, what intervals would you use? And sometimes they even put like an X and they say it's between these two. I'm using my crocodile mouths. So we could say between 100 and 200, but I feel like it won't get enough detail. I was thinking between 140 and 150, but I'm excluding 150 here because there's no equals to sign, and then 150 to 160, 160 to 170, 170 to 180, and we call these class intervals or intervals. Have I got enough intervals to cover my data set? Have I got enough intervals to cover my data set? Or do I need some more? Okay, I need one more because there's a value that's 182. And so what I'm going to do is I'm going to add one more interval. And that interval is going to go from 180 to 190. Okay, now you have to be comfortable putting something into a table. And so I'll show you the technique called the tallying technique that we use to convert list data into grouped data. So all we do is, I'm a big fan of crossing things out as we go. So we go 149, there's one in that category. In this one, it's actually 1, 2, 3, 4. You can see them here. It's nice that we've ordered it. Here, there's 1, 2, 3, 4, 5. 5. And then there's 1 here and 1 here. And so we say the frequency column says there's 1 item in this interval. There is 4 items here, 5 items here, 1 item here, 1 item here. And so this is called a frequency count, or how many items form this interval. And notice how this endpoint excludes 150, but this endpoint includes 140. Give me a thumbs up if the frequency and tally table, you've seen it before and it kind of makes sense. Okay. Now, this is nice for summarizing the data, but I want to be sure that there's a new word that comes into play this year called cumulative frequency. And the way it works is you say for an interval, you start with the first one. You say, how many items have I had so far? And I've had 1. But if I get the cumulative frequency of this data set, I count from the beginning up to this point. So at this point, how many items have I had? So if I go from 140 up to 160, I've had 5 items. And the way I did that is I added the frequency together. What do you think is going to be in the next block here? What do you think the cumulative frequency total is going to be here? Okay, so it's going to be 10, which is awesome. And then the cumulative total is going to be 11. And then the cumulative total is going to be 12. And that makes sense because we knew the end value was 12. So all I did for Tekel was I said the frequency column counts how many there are in each interval. The cumulative frequency counts how many items there have been up to that point. So over here, at this point, there have been 6 items in the data that go up to 160 and starting at 140. If I go to here, there have been 10 items between 140 and 170. And it's called the cumulative frequency or the total. And so today, because we're just getting going with this topic, I want you to understand the difference between using lists of data or groups of data. And I want to ask you another question. What is the modal interval? So what is the modal interval of data for this data set? Think about what the word, and I'm saying, what is the modal interval? Oh, sorry. So, some of you have spotted I was being a bit, thank you for spotting that. I was being a bit impor. Well done. You can't include both. You have to have it like that. Great question. Okay, the modal interval is the interval that occurs the most often. And so what we need to do is we need to look which interval has the most values in it. You can kind of see it in the list above here, but the frequency column that's highest with 5. So the modal interval will be between 160 and 170. Okay, so that's the modal interval. So you can also find where the middle of the data is when you have grouped data. And so that's something which we'll come back to in lesson 4. Okay, before we hit the second half of the lesson, I just want to just quickly go through some definitions and then we'll come back after that and do a second example. So like I said, if you want to find the mean, you add up all the numbers and divide by how many numbers you have. If you want to find the median, you have to put them in order and then find the middle one. What I did is I use what's called the position calculation for the median first. And the way that works is like that. And then I use that position to find me the value of Q2. Q2 is another way of saying the median. The second quartile is the same as the median. And the mode is the value that occurs the most often, which you guys seem to have got. Okay, so those are the 3 measures of central tendency. Now, let me leave that one out. When we come back, we are going to look at this data set and do some calculations on that. What type of diagram or thing is going on? What is this thing over here? Who has an idea? Before we head off on our break. So this is a stem and leaf plot. And what is so wonderful about a stem and leaf plot compared to the lists and the table? Why do maths teachers like stem and leaf plots compared to, say, like just plain old lists? What makes them nice? It's easier to get the median, yeah. Generally speaking, they make calculations easier because normally they're already ranked or they're already put in order. So you can see the numbers go from smallest to biggest. Also, they take less space because they use a key. So just to show you what this 1 means, it's actually not 1. It's got, this is kind of like the units, and this is the tens. So that first number has a stem of 1 and a unit of 1, so it's 11. The second number in my data set is going to have a stem of 1 and a unit of 2, so it's 12. And then we're going to have 2 values of 13. And if we keep on going, my last item in the data set is going to be 72. And so the other thing that a stem and leaf plot does is it allows us to put a data set, a big data set together in a very efficient way. And so that's why stem and leaf plots are a big favorite on exam papers. And so it just makes life easier to deal with. And so we're going to come back after the break and have a look at that. But we're halfway through, and so we need to take care of our brains and bodies so that they take care of us. So I want you to turn on your cameras. I want you to stand up with me. And I want you to just stretch out for a second. And I want you to just turn a little bit. And I want you to just rotate very gently. And then as your body starts to loosen up, I want you to just turn a little bit further. Yeah. Hopefully you can feel the backs of your shoulders loosening up. Let's roll our shoulders. So let's roll back. And while we're doing that, look away to a far corner of the room. Let your eyes relax. And then start to roll forward and look to the other side. Okay. Then shake out your arms. Get them nice and loose. Pretend you're made of licorice or something. Shake out the legs. Give them a good shake. Let's take our necks and just lean them to one side. You feel a bit of a pull here. And then switch to the other side. Oh, some nice clicking sounds there. And then let us do a tricep stretch. You should feel the nice pull on the back. And then the other arm. Okay. Oh, and then swing those shoulders nice and loose. There we go. And let's just do some small circles with our shoulders. So small circles, and I seem to be going backwards at the moment into big circles. Okay. And then change direction to be going forward with big circles into little circles. And then give your arms one more shake. Okay. Let's just take 3 deep breaths. So nice inhale through the nose, exhale through the mouth. Yeah, and then let's do some heart rate stuff. So let's do jumping jacks. Let's do 20. Jumping jack just goes like this. And we'll start in 3, 2, 1. Let's go. Yeah, that's halfway. And 10. And we are done with the exercise part of the brain break. I hope your body got some oxygen and some blood flow, and the nutrients are just swimming around. And then let us do a bit of a maths 24 puzzle just to get the brains turning. I think you all know how these work. You try and take every number on the card to make 24. And while I catch up with my breath, see if you can claim the victory. What do you think? So Impor is leading the way, it seems, with the red claimed already. The victory is yours, Impor, for the red one. my calculator is being uncooperative, me and my graphics tablet being uncooperative again. So I do see the way that you got it in Paul. Meringue, you also got it right, but we still had to use the 8 and 7. So we have to use up all the numbers. So we go 8 minus 7 is 1. And then we go times 8 times 3 to get 24. This is a 6 because this will always be at the bottom. So that's 2, 2, 5, and 6. So Nkosi has, this is a 9 down here. So that's a 9, and this is a 6. Yep. So I'm afraid, Nkosi, this is a 9, and so you cannot be sneaky like that. Who has some ideas? Who feels like they? So Andile has said 6 plus 5 is 11. See where you're going with this. 11 times 2 is 22, and then plus another 2 is 24. And then red, 8 divided by 8 is 1. 1 plus 7 is that, and then times, oh, that's for the red one. Yeah, I agree, Akanele. That isn't a good way. Okay, before I bring this to a close, anybody want to have a crack at yellow? So Nkosi has said 9 times 4 is 36, and then 36. Oh, well done. Yes. Oh, that's a hard one. So 9 times 4 is 36 minus 4 times 3, which is 12. So we have 36 minus 12, and that gives us 24. And then I see Paul has also got the blue one there in another sneaky way. Okay, well done, everyone. I like what I'm seeing in the Maths 4. Let's return back to the lesson for today. So what I want you to do for me now, I want you to find me the mean, the mode, and the median for this data set. And I'll give you, for the median, I'm going to suggest that you use the position formula for the median to help you find the actual value of the median. Okay, over to you guys. If you have a question, raise your hand and we can chat or we can converse further, but let's just see how it goes from this point. And we do need to know what n is. So, because I need to know how many data items there are. So there's 9 here, so 7 there, 4 there, 2. So what do we have? 16, 20. Okay, so n is 29. I don't want you to waste your time counting. So there are 29 items in the data set. See what you can do there. Isimayeni, what can we do for you? Can you hear me?
Sir.
What's your
Yes. Can you hear me, sir?
Perfectly. Go ahead and ask your question.
Okay. So I was just wondering, like, let's say they give us a list of numbers, right? And the numbers are like in hundreds and not just in tens of units. Then how would we classify that in the stem and leaf diagram?
Okay, the key would look different. Can you see the key at the bottom here? It says 6-2 is 62. So if it was different, the key would say something like 60-2 is, the key will tell you.
Okay.
Yeah, so just watch out for that key. But we don't generally make it difficult, like you know, like it'll be pretty obvious. It's not meant to be tricky in that sense. Good question though.
Okay, thank you so much.
So, cool. So the mode, it seems like people have spotted the mode of 17. Oh, that's the other reason. It's so nice. You can see when there are lots of numbers next to each other. So the mode is definitely 17. I need a total for all these numbers. Is anybody willing to share their total for all their numbers? When you add them up. So 935, and then I guess we have to go divide by 29. So that is going to be 935 divided by 17. Ooh, not 17, I lie. I'm just making things up now. 935 divided by 29, and we have 32.24 as my mean. Okay, so 32.24. And what about my median? Well, I first need to calculate my position. So, and it seems to be that it's in the 15th position. And so now I have to count from the beginning. 1, 2, 3, 4, 5, 6, 7. So if I count to the 15th position, I get that value there, but that's not the number 7. It is something else. What do you think the actual median is? So the actual median is going to be the value 27. And if you think about what that's the median does, it says there's 50% of the data above it and there's 50% of the data below it. And yeah, once you know how to use the position formula, life is good. Give me a thumbs up if you're feeling comfortable. Give me a thumbs down if you're feeling unsure. Okay. All right. Let's have a look at another. Okay, let's have a look at this one. This is a little bit of an upgrade one. So let's see how it goes. So I want you to do this bit over here for me. And then we'll talk about the green bit after that. So you're given a data set. Luckily, it's been ordered for you. Find me the mode, the median, and then the mean for me. So the mode is very popular, and it's agreed that the mode is 7, which I have no problems with. Yeah, we've got a bit of a problem because the position is a fraction. So what does that mean if the position is a fraction? 1, 2, 3, 6, 7. My median is over here. 2, 3, 4, 5, 6, 7, 7.5. So because the position is between two values, we actually have to average them out. And so the way we do that is we say, look, 5, well, let me do it up here. We say 5 plus 7 over 2 gives us 6. So 6 is the value of the median. And it's in position 7.5. And then what is the sum of the values, the 70, and then the mean will be 70 divided by 14, which is what? Patejo has given it to us, I think. Let's see if anybody else agrees. Camelo agrees. Kelly agrees. Ngani agrees. It is indeed 5. Okay, I think you guys have got this, so I'm ready to move on to other stuff. So a little something to sweeten the question. After writing 5 maths tests, so this is a different question. Your mean mark is 65%. What percentage must you achieve for your 6th test in order to have a mean of 70% for 6 tests? So I want to ask, what are some ideas that we could, there's a couple of different ways we can use to solve this. This is what we call a little bit more of a problem-solving question, and I wanted to throw it in to kind of start, sort of flexing those muscles for you guys. So how do you think we would do this? There's a couple of ways we can do it. Let's have some ideas in the chat. So how would you start to try and model this situation? So you've got 5 tests. You've got test 1, test 2, test 6. I like that, yes. Well, what they've said is if your average for these ones is 65, 65, the problem we have, what's the problem? So maybe, let's put it this way. If we say 65%, is everybody, give me a thumbs up if you agree that if the average for 5 tests was 5. I like where you're going, Cass. I like where you're going. Before we do that, give me a thumbs up if you agree that if you wrote 5 tests, you got 65% for each of them. Are you okay with representing it like this? Okay, now here's the big problem. If you have to get an average, okay, for all of, like, basically this one, do you agree this one is going to have to be very, very high in order to force to drag the whole average up? So how about this? We want to take this, well, let me actually show you. Let me show you this approach here. Okay, I can do it. Have a quick look and then I'll explain something to you over here. And maybe that's not the easiest way to do it. So what you could say is you could say that you need to get, so 6 times, you need to have an average of 70%. And so if you think of what 70% is, 70% is just going to be 70 over 100, which is going to be 420 over 100 or 4.2. Okay. What have you got at the moment? At the moment, you've got 65% for each one, so 5 times 0.65. And so that would give us 3.25. Okay, so what do you need to get for that last test? Okay, I will slow down, that's fine. So if you go 6 times 70, are you all happy that I'm getting, say, in fact, let's just do it that way. Let's imagine each test is out of 100. I need to end up, So if each test is out of 100, I need to end up with 420 out of 100. How much do I have after 5 tests? Remember, I need to get to 420 points. Let's put it that way. If each test is out of 100. At the moment, if I do this, how much have I got to? I got to, so 5 times 65 is going to be 325 over 100. So that's how many marks I've got so far. I've got 325 marks, and each of the tests were out of 100. I need 420. What's the difference between 420 and 325? Well, it seems to me like it's 95. And where you get those marks, you get those marks out of the tests are all out of 100. Now, that was quite another thing that is a little bit, like a harder question. And I hope that even if you don't get it perfectly, that you have some idea of how you would approach a question like that. Give me a thumbs up if showing you the thinking here helped a little bit. Okay. I just thought I'd throw in something a bit interesting. So the way I would put it is, think of it this way. Think of it as each test is out of 100. If each test is out of 100 and you got 65, let me try one more before I do the last thing for today. Let's do it this way. Imagine that each test is out of 100. And if you got an average of 65, you must have got 65 marks for each test. Okay? Now, to end up with an average of 70%, you need to get all the way up to 420, which is 6 times 70. So imagine that you want to get it, so you want it to be as if you got this. But the problem is you need to make up 5 marks for this, 5 marks for that, 5 marks, 5 marks, 5 marks. And then the last thing, you still need to get your 70. So if you imagine, you can't just get 70 for the last test, just be done. You need to get your 70 and make up the difference for each of the last tests. And each last test, you were 5 marks below. So if you got 5 marks below, what's 5 plus 25? You get 95. Does that help a little bit? So let's say like you're behind. So if you add 5 to get to 70, you're 5 behind, and you have to make up 25 marks the last test and still get 70%. Thumbs up if that helps a little bit. Give me a thumbs down if that is still confusing. I tried my best there, but it was a harder question. Okay. Don't worry. Let's just finish with one more thing today. Okay, but I don't want to, that was just the last little question. So in the next lesson, we are going to talk about how spread out the data is. And in order to do that, we need to be able to find what are called quartiles. Now, quartiles, the first quartile we call Q1, second quartile Q2, third quartile Q3. Q2 is actually just the median. Okay, and to find the median, we use the position formula of half times n plus 1. Now, you won't be surprised to find the position of the first quartile, we use the formula a quarter times n plus 1. And to find the position of the third quartile, we use the formula 3/4 times n plus 1. So to finish today, what I want us to do is try and find the median. Let us use just a simple data set. So we exclude that one. I want you to try and find me the median of this data set. And I also want you to try and find me the lower quartile or Q1 and the upper quartile using this position formula. Let's find the median first. 6, 7, 8, 9, 10. So So the median must be, I think the median is here, halfway between 17 and 18, which means the median should be the value 17.5. So that divides half the data below and half the data above. What do we think the value of Q1 is going to be? I think it's the 2 points. Is that right? 2.75? Yes, 2.75. That's half, well, that's not halfway, but we still average out between the two nearest values. So that's my hint. If you're averaging out the two nearest values to Q1, what is the value of Q1 going to be? So Q1 is going to have to be halfway between 12 and 13, which is 12.5. And then what is Q3 going to be? Well, I need the position. Maybe somebody can help me. What's the position of Q3? So 11 times 3/4, 8.25. So let's go. That was 1, 2, 3, 6, 7, 8. It's halfway between here, but they're the same value. So what is Q3 going to be? All right, so the upper quartile or Q3 is going to be 22. Because it's halfway between 22 and 22, which is 22. Now, in the next lesson, we are going to talk about how these quartiles can help us work out measures of spread or how spread out the data is. And so today's focus was on finding the middle of the data and understanding different types of data. The next lesson will focus on how do we compare data sets and say which ones are more spread out than others. Okay. Cool. I hope you enjoyed the lesson today.